In this demonstration, I'm going to show you how to perform a wind analysis on some contours and building data. I am using a tool called WindNinja. This tool is available at www.firelab.org and is created by the United States Department of Agriculture and the U.S. Forestry Service. This product was created for calculating wind patterns to use in wildfire analysis. The tool is not built for urban wind analysis, so its accuracy in urban environments is only approximate and will be used for demonstration purposes only. For this demo, I will use a raster surface as well as some 3D multi-patch building data that I have downloaded. In order to run a wind analysis, we need to create a raster surface that incorporates building height into the surface. To do this, we need to create a model. First, I will take my 3D multi-patch building tools and convert them into raster data using the multi-patch to raster geoprocessing tool. I am keeping my output cell size low here in order to improve the data resolution. Next, I need to run a Raster Calculator operation. Here, I will create a conditional statement that creates an empty boundary around my building raster that I can later attach to my terrain. Next, I need to take my output raster and my terrain raster and combine them by using the plus tool. Now, I take the output from the plus tool and place the data back into a raster calculator, creating another conditional statement to once again create a boundary for my data. The reason for these conditional statements is due to the fact that WindNinja requires a rectangular raster input. If the input is not rectangular, then we will receive an error during the wind calculation. Finally, I need to ensure that my output raster from the raster calculator is in IMG or Imagine format, as this is the format that WindNinja can read. Once my model is built, I can run my model and then add the output layer to my map document to view the output. I will now take this output and bring it into WindNinja. WindNinja has many configurable settings, and this demonstration only shows you a simple output that can be created. I recommend that you read the tutorials included with WindNinja to fully understand the project. First, I will choose that my solver will only use a conservation of mass. Next, I need to bring in my surface as an input. This is the IMG file that we created in ArcMap. Next, we need weather information. I will download weather data through the app by enabling weather model initialization and selecting the appropriate data source. Finally, I will select a shapefile output for my data. Now I can run the analysis with the Solve button. Depending on the configuration of your data, this could take anywhere from a few seconds to a few hours. When the model is solved, we can take the output path and add the data into ArcMap. By looking at the attribute table, we can see that each point has a wind direction and speed attached to it. We can now visualize this information in ArcMap or bring the data into CityEngine or ArcGIS Pro for 3D visualization of both direction and speed. This concludes the wind analysis demonstration.